So, for this morning, our topic is all about quadratic inequalities. So, let us first define quadratic inequality. When you say quadratic inequality, it is an inequality wherein it is composed of polynomial in the second degree and it is written in four different forms. So, here are the forms of quadratic inequality. The first form is ax squared plus bx plus c is greater than 0. That is the first standard form of quadratic inequality. Then, we also have the second one, ax squared plus bx plus c is less than 0. Next, aside from these two, we still have the third, which is ax squared plus bx plus c is greater than or equal to 0. And finally, the fourth and last form of quadratic inequality is ax squared plus bx plus c is less than or equal to 0. Okay, so when we say quadratic inequality, it comes in four different types or forms. It can be this one, ax squared plus bx plus c is greater than 0. Second, ax squared plus bx plus c is less than 0. Next, ax squared plus bx plus c is greater than or equal to 0. And finally, we have ax squared plus bx plus c is less than or equal to 0. Now, all of these four statements are considered to be quadratic inequality. And always take note that just like quadratic equation, a, b, and c are all real numbers. So later on, as we proceed with how to solve this inequality, you will not see any more a, b, and c. Instead, you will see numbers for those a, b, and c. Now, to make it clear, let us decode these symbols because that is the very important part of quadratic inequality. That every time you see this symbol, any of these four symbols, you can easily tell that it is a quadratic inequality because unlike equation, you can see the equal sign. Here, this time, you cannot see equal sign. Instead, you will see any of these four. So we say that this symbol, even in your elementary years, you already learned that this symbol is greater than. So this is the first symbol that will be used in quadratic inequality. Next, if it goes the other way around, it is the less than symbol. Now, aside from these two, if we put a bar below the greater than symbol, we call this as greater than or equal. And finally, if the less than has a bar below, it is called the less than or equal. Okay, so those are the four important symbols that we use in quadratic inequality. Okay, now, let us proceed with giving some examples of quadratic inequality. Okay, let's say, for example, we have this statement. Let's say x squared plus x minus 3 is greater than 0. Or the other one, let's say x squared minus 3 is less than or equal to 0. So if we have these statements, x squared plus x minus 3 greater than 0, and then x squared minus 3 less than or equal to 0, both of them are considered to be quadratic inequality. Because, as you can see, we have the form on the left side containing x squared. There are the other terms for the bx and c, and then we have this symbol greater than. While the other one, we have x squared minus 3. Although we don't have the term for bx, still it is a quadratic inequality because we have this term x squared. And then the symbol is less than or equal to 0. That means it follows the same concept with quadratic equation. even though we remove one part of the statement, let's say B or C, but still there is the value of AX squared. We consider that as quadratic inequality. Okay? Now, how about this one? 2x plus 1 is less than 0. Can we consider this as quadratic inequality? What do you think? The answer is no. 2x plus 1 is less than 0 is not a quadratic inequality because of the fact that there is no term containing x squared. Therefore, we cannot call it as quadratic statement because of that particular important thing that the term containing x squared was removed. This is actually considered to be only a linear inequality. Okay? Next, let's say for example this one, x squared plus 1 equals 0. Is this a quadratic inequality? The answer is also no. This is not a quadratic inequality. Why? The reason is that we don't have any of these four symbols because the symbol here is an equal sign, meaning this particular statement is a quadratic equation, not a quadratic inequality. Okay? Any questions? Do you have any questions so far? Class, do you have any questions about the definition and some introduction to tell if a statement is a quadratic inequality or not? You can chat me to ask questions. Okay, there's no question. Now let us proceed with the next. This time, we're going to solve quadratic inequality by giving first some examples of quadratic inequality, and then we will now solve them. Okay, for example, this one. So I already erased the first statements. Next, for example, the given statement is x squared plus 7x plus 12 is greater than 0. So that is the given quadratic inequality. From the statement itself, we consider that as a quadratic inequality, right? Because of the fact that we have the term containing x squared, meaning this is the quadratic term. We have the bx, in this case 7x, and then we have 12, the value of c. And then we have the sign, the greater than sign, meaning this statement is a quadratic inequality. Now let us solve this quadratic inequality. Okay, to solve this quadratic inequality, the first thing that we need to do is to transform it first to quadratic equation. Okay, that is the first step. We will first transform this to quadratic equation. So we will write x squared plus 7x plus 12 is equal to 0. So we remove the greater than sign, we change it to equal sign. And then we follow the steps in solving quadratic equation. In this case, the easiest method is factoring. So we apply factoring. So we write two binomials because from the equation itself, we can easily tell that we have x squared plus 7x plus 12. This is a general trinomial that can be factored out because 12 is a composite number. It has many factors, and then two of the factors of 12, when we add them, the sum is 7. So we first start with x squared, factor out x squared, we write x times x. All signs of the trinomial are positive. That means all signs here are also positive. Next, we have 12. 12 is a composite number with many factors. It can be 1 times 12, 2 times 6, 3 times 4. Among those pairs, we choose 3 and 4. Why? It is because of 7. Because only 3 and 4 can give us a sum of 7. If you try 1 plus 12 is 13, and then 2 plus 6 is 8. Okay? Therefore, we write here 4 and 3. You can interchange the two. You can write here 3 and here 4. It doesn't matter. Okay, so we have x plus 4 times x plus 3 is equal to 0. Next, we now need to apply zero product property. We write x plus 4 is equal to 0. So the other one is x plus 3 is equal to 0. Okay. And then next, we can now proceed with transferring this particular value of 4 and 3. So we get x, right, x is equal to negative 4, while here we have x equals negative 3. So we obtained two values of x. One is negative 4, the other one is negative 3. Now after that, we will now plot the answers in a number line. Okay? This way. And we will base the numbers to be written here based on the answers for x. So let me start with here. Let me write here the 0. Of course, you all know that the numbers to the right side are positive numbers. So the numbers to the left are negative. So to the left of 0, negative. To the right of 0, positive. So we have 0 here. If we extend this line, all numbers here to the right are positive. 0 is here. If we extend here, all numbers to the left are negative. Next, we plot the values of x. Let me start with negative 4. This is negative 4. This is negative 4 here. And then the other one is negative 3. Allow me to use a different color of marker. Okay. So we have plotted negative 4 and negative 3. Now, to find the answers for this inequality, we need to test some points. Okay, let us try first. Let me test any number to the right of negative 3. I will try any number to the right of negative 3. Let's say 0. I will test 0. Test 0. So, to test 0, I need to replace 0 here in the original inequality. X squared plus 7x plus 12 is greater than 0. I need to replace 0 to every x. It will become 0 squared plus 7 times 0 plus 12 is greater than 0. Once we square 0, the result is still 0. If we multiply 7 with 0, the answer is 0. Plus 12 is greater than 0. 0 plus 0 equals 0. Plus 12 equals 12. 12 is greater than 0. That is true. Okay? That means the numbers to the right are solutions for this inequality. And that gave us the idea that you need to shade from negative 3, you need to shade all areas to the right. You need to shade this part to show that negative 3, all numbers to the right of negative 3 are solutions. So you need to shade this part and arrow to show that the numbers here are solutions for the inequality. Now, let us try, this time I will try any number to the left of negative 4. I will pick one number to the left of negative 4. I will test negative 5. Let me test negative 5. So, I will replace negative 5 to the original inequality. It will become negative 5 squared plus 7 times negative 5 plus 12 is greater than 0. The square of negative 5 is 25. The product of 7 and negative 5 is negative 35 plus 12 is greater than 0. Next, we need first to add let us first add the two positive numbers for easier computation. If we add 25 plus 12, the answer is 37 minus 35 greater than 0. 37 minus 35, 2. 2 is greater than 0. That is also true because 2 at positive number is always greater than 0. That means the numbers here to the left of negative 4 are also answers or solutions, meaning we also need to shade this part. To shade this part. Now, the only part which is not shaded is this part, the part between negative 3 and negative 4. Now, let us test any point here between negative 3 and negative 4. So, let us get a number here between negative 3 and negative 4. And that number is negative 3.5. Okay, negative 3.5 is between here. Okay, negative 3.5. Or you may also use fraction instead of 3.5. So it can be negative 3.5, a mixed number, or it can be an improper fraction with negative 7 over 2. You may choose among these three. It can be the decimal negative 3.5, a mixed number negative 3.5, or the improper fraction negative 7 over 2. All of these mean the same. That is a number between negative 3 and negative 4. Let us test that using the same method. Replace, I will use the improper fraction because it is easier. It is easier to solve compared with decimal. So let me use negative 7 over 2 squared plus 7 times negative 7 over 2 plus 12 greater than 0. We need first to square this one. The square of negative is positive. Square 7, 49 over 4. Multiply whole number and fraction. To multiply them, you just simply need to multiply numerator times numerator. Negative 49 over 2 plus 12 is greater than 0. So we have two fractions and one whole number. So the LCD here is 4. So let me use the LCD 4. I will first copy 49 over 4 minus. I will change 49 over 2 to its equivalent fraction, wherein the denominator is 4. So I multiplied 2 with 2 to get 4. I need also to multiply 1949 with 2 to get the equivalent fraction. So that is 98. 98 over 4 is equal to 49 over 2 plus 12 is greater than 0. By the way, 12 can also be changed for us to easily combine the three terms. 12 can be written as 4 as the denominator. To get the numerator, just multiply 12 times 4. 12 times 4 is 48. Have that. This point, we have three fractions which are all similar fractions containing the same denominator 4. Okay? Therefore, we can easily solve. We need first to combine 49 and 48 because both of them positive. 49 plus 48 is 97 over 4 minus, just copy negative 98 over 4 greater than 0. Here, we have 97 minus 98 is negative 1 greater than 0. Now, is negative 1/4 greater than 0? The answer is false. Any negative number is not greater. It is always less than 0. Which means this area, which is between negative 3 and negative 4, are not solutions for the quadratic inequality. And that is the reason why we do not need to shade them, this area. Do not shade the area between negative 3 and negative 4 because that is not a solution for the quadratic inequality. We will only shade those areas which are solutions for the quadratic inequality. Okay? Okay. Question. Is negative 3 and negative 4 included in the solutions? To find out, you need to replace them in the original quadratic inequality for us to prove if they are included in the solution. So let me erase this one, the test for 0 and the test for negative 5, because we already have proven that they are true. Now, at this point, we will now prove if negative 4 and negative 3 are part of the solutions. To do that, we will now test them. We will now test negative 3 and negative 4. Let us first start with negative 3 from the original inequality. Replace negative 3 to x. The square of negative 3 is positive 9. The product of 7 and negative 3 is negative 21. And then plus 12 is greater than 0. To avoid error, always combine the two positive numbers. So 9 plus 12 first. 9 plus 12 is equal to 21. And then just copy minus 21. I first combine 9 and 12. 9 plus 12 is 21 minus 21, copy, and then greater than 0. 21 minus itself is 0. 0 is greater than 0. That is false, because it should be equal. So 0 greater than 0 is false. That means negative 3 is not a solution. That's why you need to put a small circle here. A small circle for negative 3. This small circle shows that negative 3 is not included in the solution. Later on, as we go on, if the inequality contains equal, you will notice that you need to shade this part to show that it is included. But in this example, negative 3 is not included. Therefore, in your graph, you should draw a small circle in negative 3. This small circle, which is not shaded, shows that negative 3 is not part of the solution. Let us test negative 4. Same, we need to replace all x with negative 4. The square of negative 4 is positive 16. The product of 7 and negative 4 is negative 28. Plus 12 greater than 0. Combine first 16 and 12. 16 plus 12 is 28. Minus 28 greater than 0. Subtract 28 minus 28 is 0. Same, this is also false. Just like negative 3, negative 4 is not a solution. Therefore, we also need to draw a small circle, not shaded, that shows that negative 4 is not part of the solution. Only to the left of negative 4 are the solutions, and then to the right of negative 3. Negative 3 and negative 4 are not part of the solution, as well as the area between negative 3 and negative 4. And that's how we solve quadratic inequality, and at the same time, how we graph quadratic inequality. Okay, any questions at this point? Do you have any questions? So please take a look at the board first. There's a question, pag false, hindi po i-graph. Kapag false, yung area na yon, do not shade or do not draw a line here. Just like, for example, here, negative 3.5 is between negative 3 and negative 4. Do not shade just that part. Do not draw a line. Only those areas na not true should be graphed, or there should be a line to show that they are solutions.